All right, this is part 3 of our lesson reviewing rational expressions and equations and inequalities and excluded values, add, subtract, multiply, divide, anything you ever wanted to do with rational expressions. That's what we're reviewing. All right, so picking up with number 23. So when you're solving an equation like this, an easy thing to do is just to multiply through by whatever's in the denominator. So I want to be able to cancel out anything I see in the denominator. Now see if you can understand why if I multiply everything by x squared, that will cancel out this, not only this denominator, but also this one, okay? So I have to multiply everything though, x squared, x squared, x squared, 3 places, all right? Now over here, that's going to leave me with negative 6x. All right, do you understand where that came from? So that's going to be plus x squared. And then, of course, these x squares cancel each other out. So that just gives me 7. So I'm going to get everything on one side. I'm going to subtract 7 from both sides. So that's going to give me x squared minus 6x minus 7 is equal to 0. All right, I just reversed the position of those two. Okay, but I subtracted 7 from both sides. Okay, so if this will factor, then we will factor it. But every now and then they don't factor, so be ready to use the quadratic formula if ever it does not factor. But this looks like it's probably going to be factorable. Negative 7 plus 1. Correct. Now, do I stop there, or do I do something else? Okay, we're solving, so we have to go x minus 7 is equal to 0, x plus 1 equals 0. Okay, so adding 7 to both sides, I'm going to get x equals 7. Subtracting 1 from both sides, I'm going to get x equals negative 1. Okay, it's good to keep an eye on our restrictions. What can x not be?
X cannot be 0.
Just 0, that's the only one. So that's not either of these, so these are the solutions to number 23. All right, number 24. I would factor this one right here, okay? So this is, I'm going to replace d squared minus 4 with d minus 2 and d plus 2. So again, I'm going to multiply through and cancel out denominators. What do you think I'm going to multiply by?
D minus 2, d plus 2.
Exactly. All right, got to do that everywhere. Okay. So I am going to cancel things out now. Anything I highlight in green is canceling out. So the d plus 2 cancels out. The d minus 2 cancels out. This whole denominator cancels out. So that's going to leave me with 2. Oh, let's go ahead and distribute this. So this 2 is going to distribute. So this will be 2d minus 4. And then might as well distribute this 8. So that'll be plus 8d plus 16. And that equals 14. All right, so 10d plus 12 is equal to 14. Subtract the 12. 10d is equal to 2. Divide by 10. D equals 1/5. And D cannot equal positive 2 or negative 2. You're welcome. I'll see you next time. Good luck on your test. All right, number 25. We must be almost done. List all of the extraneous solutions for this equation. Okay, well, first of all, the excluded values. All right, so the excluded values are coming from these denominators. So I know that x cannot equal -4 and x cannot equal 1. So those are excluded values. Let's see if any of those are extraneous solutions or not. I would just cross multiply on a problem like this. If you have a fraction equal to a fraction, simply cross multiply. What could be easier? So cross multiplying is when we multiply along the diagonal, okay? So, and set it equal to each other. So I'll have 2x times x minus 1 on one side, and I'll have x times x plus 4 on the other side. All right, so that's going to give me 2x squared minus 2x is equal to x squared plus 4x. Okay, subtracting x squared from both sides and subtracting 4x from both sides gives me x squared minus 6x equals 0. So I am going to solve this by GCF. So if I take out the x, then I'm going to get x minus 6. So my solutions will come from setting these equal to 0. So I'll just have x equals 0 from setting that equal to 0. And x minus 6 equals 0 gives me, adding 6 to both sides, of course, x equals 6. So these are my two solutions, unless any of them are extraneous. But the only excluded values are -4 and 1. So none of these are extraneous solutions. There are no extraneous solutions. There are no, unless I'm misunderstanding the question, there are no extraneous solutions. Okay, so to be clear, these are actual solutions. So off to the side here, I'm going to put the true answer to this question. There are no extraneous solutions. All right, what was that problem that we did that had extraneous solutions? Tell me the number. Okay, for example, this is an extraneous solution right here. All right, it's a solution that had to be thrown out. All right, but that didn't happen this time. All right, for inequalities, we need to get 0 on one side. So I hope you'll accept, I'm just going to do that in my head. So I'm going to have 6 over x plus 1 plus 3 is less than 0. Now, for inequalities, we will not multiply through by x plus 1 and cancel out the denominator like we do for equations. Oh no, we're going to make like denominators like we do when we're just adding. So I'm going to give this the x plus 1 and do the same thing in the numerator. So that's going to create the following expression, and I will distribute this. So I'm going to have 6 plus 3x plus 3 over that x plus 1 is less than 0. So of course that simplifies down to 3x plus, well, let me put it up here. That simplifies down to 3x plus 9, okay, 6 plus 3, over x plus 1 is less than 0. Okay, so it's time to talk about our critical values. Okay, there are two types of critical values. We have our zeros, which come from the numerator. All right, if I set 3x plus 9 equal to 0, that's going to give me 3x equals negative 9. I subtracted 9 from both sides. And that's going to give me x equals negative 3 because I just divided by 3 on both sides. Better show it though. All right, slow down, Burton, slow down. All right, so that's my first critical value, but I also need my excluded values. Excluded. Gotta sound it out. There's only one excluded value.
Can't equal -1.
So good, you're so good. X cannot equal -1, all right, because of the denominator. So we will use those critical values to form our number line. Okay, so here comes my number line. I'll do it over here. Wish I had a little bit more space. So I have -1 and -3. So here's -3, and here is my -1. So I'm thinking, are they open circles or closed circles? Well, excluded values are always open circles, because open circle means excluded. But the 0 is sometimes included. We'll know it's included when it says or equal to 0. This one doesn't say anything about or equal to. It doesn't have the little line under it. So that means we don't want to include the zeros. So we will leave that as an open circle as well. Now, we can either use test values, or we can go to the graphing calculator and take a look at that. I'm going to go ahead and use test values this time. So for my test values, I have these 3 zones. I think I'll make my little chart. Okay, I'll switch back to blue. So in my little chart, in this zone, I'm going to do the value of the function at -4, and the value of the function at -2, and the value of the function at 0. Yeah, 0 is good. These are the 3 values I will check. Now I'm going to use my TI-30 XS multi-view to help me find these values quickly. I'll use the table feature. Okay, my computer's really slow right now. So let's see, fraction mode. And what was this, 3x plus 9, I think? 3x plus 9 over x plus 1. Thank you so much. Okay, so I'm going to go ahead and just hit enter. Now my first value was -4. Okay, so I might as well go ahead and tell it -4 to start. So at -4, we get a value of 1. So I'm going to ask myself the question, is 1, and we want things to be less than 0. So is 1 less than 0? Question mark. No, 1 is not less than 0. Okay, it's positive. So now we'll look at -2. Okay, at -2 we have a value of -3. So is -3 less than 0?
Yes.
Yes. Okay, it's negative. So now I look at 0. At 0 we have a value of 9. So I say, is 9 less than 0? Of course not. 9 is quite positive. So the yes indicates where my solutions are, which in this case is between the critical values. So I will go ahead and fill that in. So this is the graph of my solutions, and now I should go ahead and write the interval notation for this, which is going to look an awful lot like an ordered pair, -3, -1, but this means from -3 to -1. And again, we left these parentheses instead of brackets For the same reason, these are open circles, all right? The -3 and the -1 are not included in the solution set. So this is the answer for number 26. All right, number 27 is a little bit extra easy because everything's already on one side. So we can actually go ahead and start talking about the critical values. So let's see. So let's talk about the zeros, all right, which come from the numerator, all right, which in this case is just x equals 0. And let's talk about the excluded values, all right, which obviously the excluded value is x cannot equal 2. So based on that, we can go ahead and set up our number line. Okay, so we're dealing with 0 and 2. And we're thinking open circle or closed circle. Again, excluded values are always going to be open circles because open circle means excluded. On the other hand, zeros are sometimes included. If it says greater than or equal to 0, they're telling us to include the zeros. So we will include the 0 by making it a closed circle. Okay, and then let's set up and do some test values. Okay, so I'm going to check out f at -1, and I'm going to look at the value at +1, and I'm going to look at the value at 3. I'm just picking a value in each one of these zones. And I'm going to use my TI-30XS multi-view. Use the table feature, okay, fraction mode, x over x minus 2. So that's x over x minus 2. Okay, we need to, I'm looking for -1 first, so I'm going to go ahead and start at -1 then. At -1, I've got 1/3. So I ask myself the question, is 1/3, and we want it to be greater than or equal to 0? And the answer is yes, that is a positive number. So now we look at 1. Well, +1, the value is -1. So we ask ourselves, is -1 greater than or equal to 0? And of course the answer there is no. It's a negative number, it's not greater than 0. And then we look at 3. Oh, the value at 3 is 3. So is 3 greater than or equal to 0? Well, yes it is. Now these two yeses show us where the solutions are. So everything in this zone is going to be a solution, so we'll show that with an arrow, and everything in this zone is going to be a solution. So now it's time for the interval notation, which has two parts to it. For this part, we're going to say -∞ to 0. Let's put a bracket at 0 to show that 0 is included. Union 2 to infinity. We'll use parentheses on the 2 to show that the 2 is not included. So that is going to be the answer for number 27. All right, for number 28, again, the entire expression is already on one side. We already have 0. So let's talk about the excluded values. We've got the zeros come from the numerator, you know. So if 2x is equal to 0, dividing by 2 gives us x equals 0. So that's one of our critical values. And let's talk about excluded values. Clearly, x cannot equal -5. X cannot equal -5 because that would cause 0. So those are my All right, so armed with these excluded values, we can go ahead and do the number line. Okay, so we have -5 happening, and we have 0. Okay, excluded values are always going to be open circle, because open circle means excluded. Zeros are sometimes included if it says or equal to 0, and this does. So we will include the 0 and showing that as a closed circle. All right, so I'm going to do some test values, one for each zone. All right, to the left of -5, I will try, how about -6? In between here, I'll just do, let's say, -1. And in this zone over here, I'll just go ahead and do +1. And to test it out, I'm going to use my TI-30 XS multi-view. 2x over x plus 5. Okay, I'm starting at -6. So I might as well just type in -6. All right, at -6, we have a value of 12. We want things to be less than or equal to 0. So is 12 less than or equal to 0? No. Now let's look at -1. At -1, we have -1/2. Is -1/2 less than or equal to 0? Yes, it's a negative number. Of course it's less than 0. How about a value of 1? If I go to 1, the value of the function is 1/3. Is 1/3 less than or equal to 0? Nope, it's not. 1/3 is positive. So this yes means that -1 is a solution. And if that's a solution, then everything in this zone is a solution. Okay, so, oh wait, I almost forgot my interval notation. Slow down, Burton. Okay, interval notation is going to be like this, -5 to 0. Notice how I use a parenthesis on the -5 and a bracket on the 0. Open circle, closed circle. So this is the answer to number 28. All right, so once again, we already have 0 on one side. So I can immediately start talking about the zeros, which come from the numerator. All right, and I can already see that x will equal 0 from that. I can talk about my excluded values, which come from the denominator. X cannot equal 3. So with those, I can go ahead and set up my number line. Okay, so I've got my 0 and I've got my 3. Now I'm thinking open circle or closed circle. Well, excluded values are always open circles because open circle means excluded. Zeros are sometimes included if it says or equal to 0. This does say or equal to 0, so we're going to include the 0 by showing a closed circle. All right? Now it's time to do some test values. Okay, one for each zone. Okay, in this zone, I'm going to check out the value of the function at -1. In this zone, I'll do the value of the function at +1. And here, I'll check out the value of the function at 4. Okay, so I can just put this in the calculator. So -x over x minus 3. All right, and the first thing I wanted to look at was -1. And look, it's already at -1, so I'll just keep it. At -1, we have -1/4. Now we want things to be greater than or equal to 0. Is -1/4 greater than or equal to 0? No, it's a negative number. It's not greater than 0. Now I look at 1. That's positive 1/2. So is 1/2 greater than or equal to 0? Yes, that's a positive number. Then I look at 4. At 4, we have a value of -4. Is -4 greater than or equal to 0? Of course not. That's a negative number. So the yes means that my solutions are here between 0 and 3. And so interval notation will be like this. We will say bracket 0 to 3 parenthesis. Okay, bracket goes with the closed circle, parentheses go with open circles. So this is the answer to number 29. Alright, I'm going to stop this video here, and I'm going to make a fourth video, apparently, for the last two problems.